Hi again. Here's lesson 1-3. I hope by the end of it you can basically say I can name polygons as our first learning target, and the second one is I know the difference between perimeter and area. Hopefully, as again, this first chapter is kind of all, some of it review, some of it just kind of establishing definitions, but hopefully you can actually name the majority of polygons, at least the smaller numbered sides, already, and hopefully you do already know the difference between perimeter and area, but again, we'll just make sure as we go along. First off, again, some definitions to write down. A polygon is a two-dimensional, so 2D figure, bounded by line segments and lies on a plane. So again, remember in 1-1 we already talked about line segments and talked about lines, and we already talked about planes. Plane in the fact that basically, again, it's that flat surface. So if you think about a tabletop, if you think about the whiteboard, and hopefully you should know some of the more basic types of polygons. Again, two dimensions, so length and width. We have triangle, three-sided, quadrilateral, four-sided. Some of you might have said rectangle right away, but again, quadrilateral is that generic. Any type of four-sided polygon is a quadrilateral. Pentagon is five-sided, and if they are all equal, and then it would be considered a regular pentagon. Hexagon is a six-sided polygon, and octagon is eight-sided polygon. Those are kind of the basics ones to basically keep in mind as we go through. As we make our way through the year, we are going to explore all these different types of shapes and different things that can be applied to them. Perimeter, so that second learning target that we had. Perimeter is the sum of the lengths of its sides. So again, perimeter is just dealing with a length type of measurement. So we start off with the first line and we go, okay, so this one's 4 plus 2 plus 7 plus 1 plus 5, and we add all those sides up to basically use the perimeter, and we remember that basically hopefully back from 6th grade. So this one would be here before, plus 2 is 6, plus 7 is equal to 13, plus 1 is equal to 14, plus 5 is equal to 19 there. So again, you would just add all of them up, and then that number for the length of the sides would be your answer for the perimeter. Area. And we're going to be exploring the different types of area formulas of different shapes as we go along throughout the year. But again, the area is the surface included within a set of lines, is the formal definition. But basically what that means is we have this shape, this polygon, that's bounded, meaning it's completely connected. There's no open spaces. All the line segments meet at a point alongside another line segment, and that space in between all those line segments is the area. So if you think about it again, the perimeter is the length of the fence, and then the area is the space in between it for any of these shapes here. Hopefully you could recognize most of these area formulas. Some of them we'll go through on later on. Polyhedron, so kind of a knockoff of the polygon. A polyhedron is now a three-dimensional figure, so we have length and we have width and now we have height. And again, remember, we live in a three-dimensional world, and so that's what we're used to. Now on this video screen, these different shapes right here are technically, because they're on a flat surface, they are two-dimensional, but we draw them in a way that then allows our eyes to basically visualize that they are popping out of the screen, or they actually have that extra dimension to them. And so again, we have our cube, and we have our basically pyramid-like shapes that are three-dimensional, and then we get into kind of some more complex ones. Now again, a three-dimensional figure bounded by polygons. So instead of our polygons being bounded by line segments, we now have three-dimensional figures being bounded by their two-dimensional counterparts. So for our cube right here, we have it's made up of squares. Here it's made up of triangles, and then pentagons, and then our equilateral or just regular, just basic triangles. Couple things to keep in mind when we actually talk about a polyhedron is to talk about kind of more the specifics. We have edges of a polyhedron, the line segments in which the faces of the polyhedron meet. Now again, I'm going through all the definitions here, and then I'll be able to show you a picture later on. And so the edges again are line segments in which the faces of the polygons meet. The face of a polygon is the side of a polyhedron, and they all lie in a plane. So if once you get that written down, third part of a polyhedron is the vertexes, or just a plain vertex is the corner where the faces meet on a polyhedron. And so here's a picture to kind of basically represent all three of these. So again, the edges are line segments in which the face is the polygon. So basically those polygons that make up the sides of the polyhedron. So here's one face, and this yellow over here is also a face, and where they meet is all along this line right here, which we call the edge. You can't see it, but underneath there's again other faces that are underneath this, and so this line here represents an edge. The face obviously is just the polygons that make it up, and it's that flat surface that lie in a plane. And then the vertex is at the specific point. So all these edges, all these corners basically meet up at this one specific point, or here's another point, or another point there. With an actual pyramid itself, again, I want you to just keep in mind, and this is kind of for more of the homework basis, because you will be asked to look at pyramids or basically create a pyramid yourself, is we typically have the base of the pyramid, and then all of those corners have line segments that the edges go all the way up, and they all meet at a certain point here, the vertex, or specifically with a pyramid we call the top of that the apex. A specific height of a triangle is basically from the base going straight up. Alright, it is perpendicular to the base. If you can kind of visualize it, if I move this line, slide it over, and drew a line straight from the apex straight down to the base, that would be the actual height of the pyramid. And the slant height is where, again, it's going from one of the edges and it's just going along the face, and it slides all the way up. So again, please know that these types of kind of definitions as we explore different pyramids. And last slide that we have for you is basically kind of an exploratory thing. I want you to look at there's different, again, with three-sided polygons you have a triangle, and four-sided you have a quadrilateral. I would like you to, there are 11 up here, so 20, 30, 40, 50, 60, 70, 80, 90, 100, 1,000, and it's getting cut off right here because I couldn't fit it all on my screen, but 10,000 here. There are 11 different ones up here. I would like you to see if you could find the names of what is a 20-sided polygon called, what is a 30-sided polygon called, what is a 40-sided polygon called, all the way up. See if you can find 6 of these is what I'm going to ask of you. Okay, so there are 11 up there. I'd like you to find 6 and see if you can just look on the internet and find these out, because the names, and they might actually be familiar to you as you start to explore them. Again, we will go through the 1-3 homework in class on our next class period, and so please just complete 6 of these for the class period, and if you have any questions, please feel free to come and talk to me. Thanks for listening, and we'll see you next time. Thanks.